All right. Hello, everyone. Welcome back to another episode of Gradient Descent, where we go really deep into a specific AI topic for the week. And my name is Vishnu, and the founder and CTO of WiseCube. And I have here with me Alex Thomas, who is my colleague of long time and the principal data scientist at WiseCube. Hey, Alex, how are you
Hey,
feeling this week?
I'm feeling pretty good. Working on some cool LLM stuff, and yeah, I think that one of the cool things about like being able to talk about these things is that as part of like the research for this, we get to go out and find really cool stuff that we can then bring into our work. Um,
Yeah. Speaking of which, so this episode's topic, we decided to go talk about prompt engineering. Now, those of you who've been sort of living under a rock for the last 2.5 years, Alex, how would you describe prompt engineering?
so I would say it's a mixture of best practices and alchemy, um, where we're writing these like natural language instructions and inputs for LLMs, and that becomes sort of like one of the main ways of tuning what your program is doing. But because it's natural language, you're just putting this big string of text. Um, it's a lot harder to modify it and improve it in a like, systematic, deterministic way. Um,
Yeah, I think
so
of it as modern day spell casting.
yeah,
Is that accurate?
yeah. You're just we're gonna find like the right arcane words that will summon valuable
summon,
insights.
summon the dragon. Yeah.
Yes.
And then we have these books people are starting to put together, which, there's spell books that just, they carry around. It's like it's always
Yeah.
guarded with highest of secrecy, and then people add to them. And or you can also think of it as LLM whispering is another term that I like to use.
Yeah.
You just have to know what the right thing to say to get the right things out of the LLM, in the right tone.
And in the right tone, like controlling what the output was, the format of the output, is actually something that now it's becoming less of a problem as there's like the DSPy, which is the tool we're talking about here. We have now structured outputs in most of like LLM serving software. But like it was a thing that was wrestled with for a long time because people didn't want arbitrary text returned; they wanted like structured data returned. Um, and it's interesting. Like if you think back to like 2022, 2023, so much of prompt engineering was about getting the correct output, the correct format for the output. Um,
Mm.
uh,
And yeah,
yeah, so
speaking of that, so what were the problem? What are some of the problems that are still prevalent with prompt engineering and the way people interact or get the LLM to do stuff? Right. I mean, basically, that's what it is. They're trying
yeah,
to, you know, have the LLM do stuff for them by sort of coming up with this very handcrafted pieces of text. Um, and what are some of the downsides of that? You think?
yeah. So I say like as far as like what are like common people are trying to work with with prompts today, we're trying to work through. Um, the output issue I would say is largely solved. You still do have the problem of even if you're using like structured outputs or using some other library that does it, of the LLM still failing to produce correctly formatted results. It's not super common unless you have a very complex data structure you want to put out, but it can still occur. The other stuff is like when you want to do few shot, sort of like how you do that. And I think there's sort of like a larger meta problem around like as you're trying to tune these prompts. There's a lot of sort of like these problems that are a lot more fuzzy in terms of how they appear. So, for example, if you have an overly long prompt, important parts of your prompt can be forgotten if they're too early on. So if you have like the main description of your problem early on in the prompt, and then you have like a lot of very large examples, or you have lots of additional data after that, it can muddy the water of what your prompt's actually supposed to be doing.
Hmm.
Um,
Yeah.
yeah.
And then it just, it, I find the whole process still very sort of brittle and like, a lot of text manipulation. I know there's frameworks that have come to sort of like address some of these concerns,
Mhm.
but you still have to create these hand coded templates. And I don't know, it's not very modular. It doesn't feel
Yeah.
like you're programming. It feels, you know what it feels like? It feels like early days of web programming. For those of you who are old enough to know, in the in the early days, like you would actually go and like try to like have like templates of pieces of HTML, and then you would inject like stuff in there, and then then JSP came along, Java, through pages, and that was like, oh my god, this is so much easier. And it just sort of feels like that because you're dealing with a lot of text and mixed in with logic, and you're trying to do stuff, and it's not very modular to be able to do this kind of thing. And of course, we've come a long ways around web programming since then. But I feel like that's sort of this phase of maturity that this whole prompt engineering space is right now. I don't know what your thoughts are, but
Yeah. So like, there's definitely, you can see the community is sort of like very organically and not in any sort of like organized way, but like they're moving towards trying to add this structure into it.
mhm.
Like that, like lang chain and lang graph. That's an effort to add structure into it. Um, uh, there's been like other sort of developments more on like the LLM generation side, like chain of thought, which
Mhm.
was something that was like has been developed, been developing for a while, and is out, and has been around now for a while. Um, but even like with chain of thought, it's sort of like the there are good explanations for why it improves, but it doesn't give you many knobs in the way of like how you control what you're doing. It does give you
Right.
like some, you can talk about the depth of of a thought, and there are even like more complex ones, like sort of like with multiple outputs and stuff like that. So like it gives you some knobs, but like because the things you're talking about with the early days of like HTML, and I think like another important like thing there where like still when you're doing a prompt, there's going to be lots of experimentation of like, can I get the LLM to do the thing I want it to do? So like people like you mentioned with HTML, you didn't necessarily know how it was going to appear depending on like what browser and what platform it was
Hmm.
working on, and so
Yes.
you would just
Yes.
sort of write it, and like hopefully if it doesn't work on someone's computer, they'll send the webmaster an email. Um,
Yes. Yes. Webmaster. There's a term. Blast from the
yes,
past. I don't think anyone's used that for like last 15 years.
yeah.
Once.
And if anyone else understands that term, how are your knees doing? Um,
Yeah. But
uh,
which brings us to okay, and today's episode, like where we wanted to talk about how some of the new advancements in this area, like in where people are trying to make this more structured, more modular, to make it more look more like programming instead of just string manipulation and text manipulation and so sort of trying to say the right words. Um, and one interesting sort of framework that caught my attention was this thing called DSPy, which I think it stands for declarative self-improving pipelines, but we'll talk about all of those. But you've been playing around with it more recently. Um, yeah, what are your thoughts on what it is, and like what are some of the key components of DSPy at least?
so I think that there's a couple of things worth like calling out separately from it. One is how it helps you like organize your prompts. Um, it sort of like has like the input and output types that's something that's like a very intrinsic part of how it works. Where you need to specify your inputs and your outputs. And so it does definitely checks the box on helping you organize the different interactions with
The
with the
signatures, right? Yeah, they have these
exactly
concept
signature.
of signatures where you can just define almost as an annotation hey, what are the inputs and outputs that my LLM function takes,
Yeah,
and then that sort of becomes the foundation for building up from there, which I really, and that's something that most programmers will probably relate to, right? Like if most programming languages do have a concept of annotations on types of functions, like as a Java programmer, yeah, you always have these annotations that you add that get that help another framework understand what you're trying to do with your function or your
yeah.
class. So anyway,
And I would say like
good, yeah.
one thing that I say like I do like it better than like a lang chain. With lang chain is very much like built in like sort of like it's even like in the name is built into this idea of like a pipeline or like a chain thing. So
Mhm.
um, one of the things that on a side project I've been working on is building a Streamlit program that's doing a lot of LLM interactions. And if you're using, let's say, LangGraph and Streamlit,
Mhm.
well, they both have sort of like a state machine that's running, and
Mhm.
it's really difficult to interweave them. What I like about DSPy is that it's less about sort of like stringing together multiple things, and it does a really good job at defining sort of like the atomic interactions, as well as you can define more complex sequences of interaction.
Pipelines, yes,
Yeah,
and
exactly.
they do have a concept of pipelines. They call them modules, but
Yep.
yes, you can have a very simple predict module where like, hey, I'm just question answer, or you can have a chain of thought. They have built-in modules that you can
Yep.
use that are more like stereotypes, if you will, and then depending on what kind of interaction you're having with the LLM, you can choose one or the other. But to me, where it really sells me is like, hey, okay, not only have they be able to define and modularize and make this more structured programming experience, but also then sort of introduces this optimization angle into it, which at least for me was like, hey, this is really cool because then it's sort of I don't have to keep doing trial and error and and all of these other things that people are doing now in order to figure out how to tune my LLM. Talk to me about how people are tuning LLMs this, or like sorry, prompts these days.
Yeah,
And
I think sort of like the thing is like, are we talking about like prompting? Are we talking about two elements? I do think like sometimes like the artificial separation of those two. I understand why they're separated, but sometimes I think it's more useful to consider them as part of the same bucket. Because like you have some sort of interaction or set of interactions with the LLM, um, uh, and you want to improve your output, and that can of course be done, fully on the prompt side, and that's where we get stuff like, like trying to tune the language in your prompt. A few shot tuning is few shot examples, um, as well as like um, working with different ways of constraining the output. Like there's lots of things you can do on that side, but also you can fine tune the LLM or build a LoRa model or any of those things are like more on the modeling side. Um, and I know with DSPy they actually have this concept of optimizers, and
mhm.
I think there's like three cool ones I think are worth calling out. One, they have one that can do, you can do the few shot examples. It's sort of like one of the main ones that they built an example for. I built a reference implementation for optimizers, and they have different methods for picking the right answer. You can like one was like a KNN one where I could find
Mhm.
the most similar examples that you've provided it. Um, and that's something that before using this, like I've implemented it multiple times, sort of like depending on what project I'm working on,
By
where you
hand.
have to by hand. And like I really think that as far as for like future, I think we are going to the way where it's sort of like sorting. Like the old people who worked with it will be like, in an interview question, implement
When
canon
you say
future.
just these serving, you mean model serving, right?
Sorting. So it's
So
sort of like with
sorting.
programming,
So
how like back in the
okay.
day, you would often have to implement your own sorting algorithms before like standard
Yeah.
libraries became stock common.
Yes.
And I think that the few shot stuff here is gonna be like that. Like I think probably in like 5 years, no one's implementing their own few shot. It's all going to be from a library, and there's going to be different ways of like tuning it. Or yeah. Another one is actually tuning the prompt itself, and I think this is like an attempt at getting towards like the most sort of magical alchemical element, which is like the core of what you're asking the LLM to do. Like that is like fundamentally, it's not a structured thing. It is free text, and it has some optimizers in there about trying to improve the language of your core prompt. And I think that's going to become more common, especially as the data sets that LLMs are trained and updated on begin containing more and more information about LLMs and prompting. Like it's going to become more and more feasible to build some sort of interaction with an LLM that improves a prompt.
Right. And I think to me this is the most important thing about frameworks like DSPy is, or maybe the next stage of the evolution of prompt engineering and prompt optimization is, hey, a prompt is not just a static artifact anymore, right? It's not something you just come up and you just tweak and you just come up with that and you let it be just like that. You can actually treat it as a learnable function, right? Which is it's very exciting to me. It's because now, hey, it's almost like hyperparameter tuning. It's like, okay, we just have this set of things that are, yes, just happens to be pieces of text, but there is a direct correlation between the text in your and like your output that you're trying to accomplish and the loss function, that you're trying to measure yourself against. And so now it becomes a thing that you absolutely have to learn to see what is the most optimal solution for it, just like any other machine learning, a solution, right? So
and I think one of the things that's like sort of this bit of barrier and why it's like just coming around now, if let's say you look at other hyperparameter tuning, so let's say you're looking at like estimator depth, tree depth in random forest, right? That's a number, that's the space you need to search, and you have your metric and you need to search it. Okay, that's really easy to do. You have, let's say, neural networks where there's you can try and tune around like the architecture, like how many hidden layers you have, or the dropout, or what dropout layers you use, or that all that kind of stuff. And like that's of course a more complicated space, but it's definitely a highly structured space. We know how to search that. What happens when your space is natural language? Like that's a really difficult space. And really, the LLM is sort of the only tool we have that can actually search that space. So one of the things they have there, they have metrics. And so like once you have your module and you have your metrics, it can then try and use the LLM to tune your prompt, given your whatever sort of data set, your dev set that you give it to tune on. And it's a much more, of course, like as a hyperparameter, it is extremely more difficult to search than like anything that's come before. But with LLMs, like, you can actually do that.
Right. Yeah. No, I think this is why I find it pretty exciting that, hey, there is at least this attempt at trying to get a handle on this and treat it like any other machine learning problem. And give some primitives that are going to help with this and some structures to think about this, right? And that's great. So let's say maybe, I don't know if it would help, like in terms of just walking people through how you would actually go about using this and what are some of the things that you would have to do. And I've been also playing around with this for like a different project. And I'll be honest, like it's been a while since I started playing around with Python, and it just took me a while. But like I found it, even then, it was pretty sort of intuitive to get into their ecosystem and trying to understand, okay, define the signatures. I might have used some vibe coding, I will admit, but once the concepts were very easy to follow. Yeah, there's these signatures, there's these modules and optimizers, and they also have, you can define your own set of, they call them examples. So they have a class called example where you define your data set as an example. And then to your point, you can then have a set of examples that are your training set, and the set of example as your test set. And then you define what's known as an evaluator, which is really how you're going to measure how good your prompt is, and then you can define your own loss function, your own
Mhm.
like scoring function,
Yeah.
and then saying, yeah, this is how I want to measure how good it is. And then you set all of this up, and then you let the optimizer do its thing, and then saying, hey, go do the best you can on this prompt, and then I'm going to try to evaluate it. Of course, you can try to evaluate it before, after the optimization. You can save the results of your optimization as a pipeline that you can use for serving up later. So there's all of these very nice features, and they have like good documentation that I was able to follow for the most part to try to get stuff done. I don't know. What were your experience? I know you're going to start playing around with it, like in some of
Yeah.
the projects that we've been working on. But what were your first impressions on that documentation? And
So, one of the things I like in a library is I like it to be composed of like atomic elements. So, like one of the problems that I sort of had with LangChain, as I mentioned earlier, is that like if you build like a very tiny thing with LangChain, you sort of like it sort of feels like, oh, I'm not really using the full library. You sort of definitely feel like, oh, I need to be building stuff on top of this. With DSPy, just like building the thing for managing like your signature, is it it feels like, oh, this is a complete concept that you can then build on if you want to, but like it doesn't feel like it doesn't feel like you're only partially using the library. So I think that for people who are like first implementing this, just what you said, like it's really easy to like get started on it. The other thing is, I think that as far as for the optimization stuff, I would recommend for people with a normal like machine learning thing, you sort of want to like understand your problem and then start figuring out how to optimize a program or a model or what have you around it. So I would say, yeah, definitely like play around with like the base things and then start working towards optimization. And like they have a lot of the other stuff in this sort of like standard, like there's tool usage that they have. Um,
yeah,
and yeah,
and just to add to your point, because you don't have to use the optimizers. In fact, the optimizers are completely optional. You can just set up your signature, your modules, and set up your examples, and then you have your evaluators,
yeah,
and that's it. And you have a pipeline that you can measure how good it's doing. You can
yeah,
baseline it, you can see, right? And that's sort of what, to your point, most people should start there, which is like,
yeah,
hey, do you have this thing? You have like a very complex hyperparameter that you're feeding into this LLM called your prompt. Let's just see how well you're doing as a baseline. Set up your
yeah,
evaluation, set up your examples, and just start there. And once you have an idea of how good your current prompt is, even if you were going to do your prompt tuning by hand, right? You will
yeah,
still be able to measure, are you getting better or worse, right? This is just basic like AI machine
yeah,
learning development hygiene, right? This is that everybody should be doing this. There shouldn't be building an AI application where you don't know how good you are in a measurable, quantifiable way. You don't have an evaluation, you don't have a scoring function set up, because you need to think through these things. And fortunately, for people coming in, maybe not with a machine learning background, some of these things mm, may not be second nature to them,
yeah,
right? And so they just like, oh, I just set it up. It looks fine. I ran a few examples. It looks
yeah.
good. I'm going to ship
The
it,
spot check.
right? Yeah, the spot check. And I feel like this is the other reason I like frameworks like this, is because it brings back the rigor that you
Yeah,
need while building, probabilistic, non-deterministic applications and pipelines, right?
yeah,
Because by definition they're very non-deterministic. They're just going to do what they're going to do, and depending on what examples you feed, the results might vary drastically,
yeah.
right? So
And
anyway, yeah,
I think there's there's another thing I wanted to mention. Um, Yeah, so I actually wanted to bring up something you had mentioned before we started recording about when you switched from just like a basic like prediction to using chain of thought, and like how
mm,
easy it was to do, and like you mentioned how you just switch because it's just like a very like simple change of one line of code, and you immediately saw an improvement in the quality of what you were doing, um,
hmm
and I think that having a library that minimizes a lot of like the software complexities is very important in helping the community move forward, because there's lots of people who are now working on prompts and like LLM interactions and stuff like that, who are they're not necessarily strong software engineers. Like both me and you, like we have a long history of like software engineering and as well as data science stuff, but like maybe they don't know how to do that. Well, if they know some basic Python, you can work with this system. It doesn't require any sort of like advanced concepts.
Right.
Yeah, I think that this sort of like very good, very simple modular design. Yeah, I think that's going to be very important going forward for a lot of people, because it's going to make it this sort of work a lot more accessible. Because we also mentioned sort of before about the spot checking, and there's a lot of money, a lot of manpower, human power, whatever, going into developing LLM applications, and a lot of people, they don't know, even if they do know that, oh, we should be evaluating, should be testing that, even if they know better, they don't know how to do it. And one of the cool things they have in here in their sort of like their tutorial documentation is they talk about that you can actually build not just like LLM, build LLM as a judge easily into your metrics. So if you're, let's say, with an example they give as a question answering one, where they have a metric where it's like it's about like trying to build something that can answer questions via Twitter. So the three parts of their metric are: does this correctly answer the question, which is something they leave up to the LLM. It's classic LLM as a judge. Is it engaging, which is again is left up to the LLM, and then checking for character limits. And like,
anyway, for those of you, we did do an episode on LLM as a judge before. If you want to get deep into that, refer back to that episode. But yes, I think those kinds of techniques, because and I think this is the reason, right? Because it's also very modular and very sort of composable and reusable. It becomes so much easier for people to try these new techniques and sort of incorporate them into these into their programs, and it looks more like programming. And this is the other thing; it just becomes more like programming with like functions and modules, instead of just these arcane frameworks that have their own concepts that take you away from regular programming style or whatever the language is. In this case, it's Python, right? And so if you would show me like a DSPy program, it would just look like any other Python program. Like I would be like, yeah, this is just a regular Python class with some annotations. That's what it feels like, at least. And so I think it's definitely a step forward, I feel, for people who are trying to build AI based applications in a much more modular, much more maintainable manner, and it makes it much more reusable for the future as well. And goes moves away from this whole string manipulation paradigm, which I don't think is really sustainable. Anyway. In terms of I think next steps, where do you see like this whole paradigm going? What are some of the things you would like to see in frameworks like this, or like in generally in the way people are, we're building AI based applications and LLM based applications in your mind?
I think right now, like for example, in this they talk about like you can implement your own metric, and I think that's good and it's very convenient. I still think the community needs to start gathering around certain like metrics or families of metrics, so that things can more easily be compared in an apples to apples way. Because you have one of the difficulty of like someone comes out with their new system, and like they measure their specific task, and understanding that's where they're measuring it. But then it's hard to say if you have two different people solving similar but not identical problems. It becomes really hard to compare and decide like, okay, well, who's actually doing better here? I think that there's also
that was interesting, because I ran into the same problem too. I was trying to produce some structured output, and initially I struggled. It's like and then the LLM kept prompting like, oh, you should just flatten all the text and just compare. And that was terrible. Like I just kept getting zero. Like, oh, you're zero. Your score is zero, no matter what. And I was like, oh no, we gotta, because this is also sort of an art, like trying to figure out what your scoring function needs to be,
Yeah.
how you want to measure yourself. It's not straightforward, to your point, right? For some things, I think there are some standard things that are starting to emerge for like RAG based systems, and there's some metrics that's starting to emerge, and question answer, and so on. But let's say you are producing some complex structured output, which more and more people are trying to do with agentic AI and whatnot. They want to be able to generate functional calls and like make API calls and things like this with tooling and whatnot. So then I do think there needs to be some more clarity around how do you measure structured output, and then and all of that. In my case, I was trying to generate like this SML thing, and like and eventually I just went with an embedding model to sort of score the whole thing and just give me like the closest score and like do a cosine similarity. But is that the best thing? I don't know, right? I still have to
Yeah.
like go and look into it and seeing if I can do better, right? Because at the end of the day, it all comes down to that. Like if you don't know how to measure yourself, and you can't come up with a very precise way of measuring what is good, how would you know how to optimize and fine tune this other magical thing that you're feeding into this giant model?
Yeah, and I think that like by default in a lot of situations we end up, so whenever we talk about like a metric, there's sort of two layers to it. There's like the example level metric, and then there's the data set level metric, which is going to be like some aggregate on the example.
Mm-hmm.
So
Mm-hmm.
I think a lot of people default to just like a binary concept of correctness at the example level.
Mm-hmm.
And whereas like if you have a large data set, that's perfectly fine for measuring it. But one problem it has is it doesn't give you a lot of like detail when you're measuring. So like for example, in your case, you're generating somewhat sophisticated output, and it's then structured. And if you just simply say correct or incorrect, then it's exactly the sort of problem. Like you're going to overwhelmingly have a super low score, and it'll be very hard for any sort of optimizer to like make progress on improving it, right? Because it's not going to get the detailed information of like how wrong was this, how close to correct was this, what were the problems. So I think that I sort of see going sort of in a direction where the aggregations that we use for measuring across these data sets to have pretty standard ones for those, and then to have sort of like a parameterized concept of example level correctness. And like you're already sort of seeing them like when they're measuring generated code, they're doing that. You're not just like they're not just saying like, oh, was this the code I wanted, or does this code like for example, I think this is a good start. But like, does the code like run and produce a correct answer? It's still just sort of a binary concept of correctness, but it still gives more flexibility to the system as far as what is correct. Yeah.
No, that's very interesting points. Yeah, I think people need to think about these things, and I'm hoping that frameworks like this they sort of force people into at least thinking about these problems before they embark on their next AI application. Hey, how in fact, they should, right? They should start with how are you going to measure your example level metric, as you say, and the data set level. Once you have a good idea of how you're going to measure, then it becomes a lot easier to do optimization, and all of these other things, and see how it's impacting your problem task at hand. And then, of course, you can add various things and add more data and add more this and that, and then see how, and run all those different experiments to see how well you can do, or how much better you can do, right?
Yeah, to reference back to our LLM as a judge episode, like when you're embarking on a new application that's not sort of like a cookie cutter, oh, there's stuff out there for already. Like maybe it's specific to just like your business use case. Like there's going to be a need to gather data, even if you are going to do LLM as a judge, you're going to need to like gather some stuff initially, and be able to have your concept of correctness of your metric is essential to that. So I think that the more good libraries like DSPy come out, the more it allows this sort of community knowledge and best practices to begin applying to this new technology. Which right now it's kind of hard because a lot of people, they don't know how to do it. As I mentioned, like spot checking's still pretty common.
Yeah. Well, with that said, I would love to, have people go check out this library. Obviously, consider the things that we've talked about here, and hope this helps your journey into building more cooler AI applications. And thanks a lot for tuning in. If you've been listening so far, and hopefully we'll see you again in the next episode of Grading Descent. Thank you, Alex.
Thank you.